In today's video, I'll discuss about reduction formulas and also the indefinite integral of some trigonometric function. I will start from the reduction formula. They are derived based on integration by parts. The integral of sine the power of nx dx. So the first step, we can write this by applying the exponent rule. This can be written as sine x times sine raised to n minus 1 x dx. We wrote it as a product of two functions. Then, remember what we discussed about integration by parts. Using integration by parts, let's represent u, that is sine raised to n minus 1 x, and v prime sine x. From this, u prime will be the derivative of sine raised to n minus 1 x, a composition function, apply chain rule, and then you'll get n minus 1 times sine raised to n minus 2 x times the derivative of the inner function, sine x derivative, cos x, and the indefinite integral of the antiderivative of sine x, that is v. V will be minus cos x. Okay, then when we apply integration by parts, this becomes sine raised to nx dx. The integral is equal to, look, the integral of u v prime is equal to, diagonally here, uv, that is minus sine raised to n minus 1 x cos x minus the integral of u prime v. Here you have minus sign. Therefore, this becomes plus the product of the two, that is n minus 1 times sine raised to n minus 2x times cos x, cos square x dx. Then here we know that cos square x means 1 minus sine square x. Therefore, this can be written as minus sine raised to n minus 1 x cos x plus n minus 1 times the integral of sine raised to n minus 2x times 1 minus sine square x, that's cos square x dx. Then distribute this value, multiplication distribute over addition, is equal to minus sine raised to n minus 1 x cos x plus n minus 1 times the integral of sine raised to n minus 2x times 1 minus sine raised to n minus 2 sine square n minus 2 plus 2n, that is sine raised to n x dx. It will give us minus sine raised to n minus 1 x cos x plus n minus 1 the integral of sine raised to n minus 2x minus n minus 1, this common factor, the integral of sine raised to n x dx. You have dx. Now, this is the integral of sine raised to n x dx. On the left side, we have Here, the integral of sine raised to n x dx. So we can add this value. Therefore, this gives us the integral of sine raised to n x dx plus this value n minus 1, the integral of sine raised to n x dx is equal to, here, minus of sine raised to n x, n minus 1, sorry, x cos x plus n minus 1, the integral of sine raised to n minus 1, n minus 2 x dx. Then from this we got here, look, 1 plus n minus 1, that is n times the integral of sine raised to nx dx is equal to minus sine raised to n minus 1 x cos x plus n minus 1 times the integral of sine raised to n minus 2x dx. Then divide both sides by n. Both sides by n. Then the integral of sine raised to nx dx is equal to minus 1 over n sine raised to n minus 1 x cos x plus n minus 1 over n, the integral of sine raised to n minus 2x dx. This is the reduction formula for sine function. Now similarly, you can proceed. The integral of cos raised to nx dx. This is how we derive the reduction formulas. Now, let's apply these formulas for some problems. Let's see examples. Let's evaluate this indefinite integral, sine cubed x dx. Solution. By using reduction formula, the integral of sine cubed x dx was n is 3. Therefore, minus 1 over n, 1 over 3, sine raised to decrease by 1, sine square x times cos x plus n minus 1, 3 minus 1, 2 over n, 3, the integral of decrease by 2, that is sine x dx. So the result will be minus 1 over 3 sine square x cos x plus 2 over 3. What's the integral of sine x? Minus cos x plus c. Minus here, our answer will be minus 1 over 3 sine square x cos x minus 2 over 3 cos x plus some constant c. This is the answer. Let's see the other example. Evaluate the indefinite integral cos raised to 5x dx. Solution. The indefinite integral of cos raised to 5x dx is equal to, look, cos 1 over n, n is 5, 1 over 5, decrease the power by 1, cos raised to 4x times sine x plus n minus 1, 5 minus 1, 4 over 5, the integral of decrease n by 2, cos cubed x dx is equal to 1 over 5 cos raised to 4x sine x plus 4 over 5 open bracket and apply again reduction formula for n3. Therefore, that will be 1 over 3 cos square x decreased by 1 times sine x plus n minus 1, that is 2 over n3, the integral of decrease by 2 cos x dx. Then distribute 4 over 5, 1 over 5 cos raised to 4x sine x plus 4 over 5 times 1 over 3, 4 over 15 cos square x sine x plus 4 over 5 times 2 over 3, 8 over 15 times the integral of cos x sine x plus c. This is the answer. Let's see another problem. Here we have the integral. Evaluate the integral of sine raised to 5x cos raised to 4x dx. Now it is a little bit different from the above two examples. What we have to do here, always we need to focus on the odd power. Solution. Now in this case, look, raised to 5 raised to 4. So what we need here is the odd part. The integral can be written as the integral of the odd. Take sine x as a factor, then you'll have sine raised to 4x times cos raised to 4x dx. We have even power here. So even numbers, whenever n is even, you can write as 2k. So here form is 2 times 2. This can be written as the integral of sine x sine square x raised to 2, that is 4, cos raised to 4x dx. Then from trigonometric identity, we know that sine square x means 1 minus cos square x. Therefore, is equal to the integral of sine x in bracket 1 minus cos square x the whole square times cos raised to 4x dx. Now sine x, cos square x, cos raised to 4x, composition function, the inner function cos x, its derivative sine x, integration by substitution. So let's u be cos x. This implies du by dx is equal to minus sine x. From this, we obtained du minus du is equal to sine x dx. Look, sine x dx, sine x dx. Therefore, our integral is equal to, look, sine x dx, that is du minus du. We have minus sign. So minus the integral of 1 minus cos x u square the whole raised to 2 times cos x u the power of 4 du, that is sin x dx, sin x dx minus du. Here we have the minus sign. Now this is the integral of polynomial function minus the integral of 1 minus u square 1 minus 2u square plus u to the power of 4 times u to the power of 4 du. Then distribute u to the power of 4 minus the integral of u to the power of 4 minus 2 times u to the power of 6 plus u to the power of 8 du. Then integral of polynomial function. We have minus in bracket u to the power of 4, u to the power of 5 over 5, n plus 1 over n plus 1, minus 2 over 6 plus 1, 7 u to the power of 7, plus u to the power of 9 over 9, plus c. But what is u? Cos x. Therefore, the integral is equal to minus u cos raised to 5x over 5 minus minus plus 2 over 7 cos raised to 7 x minus 1 over 9 cos raised to 9x plus constant c. This is the answer. Okay, let's see another example. To integrate sine 5x cos 3x dx. First, let's derive the general formula. The integral of sine ax cos bx dx. Remember the trigonometric identity. Sine of a plus b is equal to sine a cos b plus sine b cos a. The other trigonometric identity for the difference, sine a minus b is equal to sine a cos b minus sine b cos a. Look, this term and this term, they are the same but opposite in sign. Therefore, add downward. Sine a plus b plus sine a minus b is equal to sine a cos b, sine a cos b, 2 times sine a cos b. From this, we got sine a cos b is equal to, divide both sides by 2, 1 over 2 sine a plus b plus 1 over 2, this one, sine a minus b. So here in the problem, look, ax represent for a and bx represent for capital B. Therefore, the integral of sine ax cos bx dx is equal to, look here, integrate both sides, integrates one, integrates one. So here you have ax represent for a, bx represent for b. Therefore, this is the same as the integral of 1 over 2 sine a plus b, that is ax plus bx. Therefore, it will be a plus b x plus half sine of a minus b x dx. Now it is very simple to integrate. The integral of sine 5x cos 3x dx is equal to half the integral of sine of the sum 5x plus 3x dx plus half the integral of sine of 5x minus 3x dx is equal to half the integral of sine 8x dx plus half the integral of sine 5x minus 3x 2x dx. Then 1 over 2 the integral of sine 8x. Sine 8x minus cos 8x over the coefficient 8 plus half the integral of sine 2x minus cos 2x over 2 plus c. Simplify. Minus 1 over 2 times 8, 16 cos 8x plus, here you have minus, so minus 1 over 2 times 2, 4 cos 2x plus c. This is the answer.